Okay, let's look at the comparison of fractions. So assuming you are given a number of fractions to compare, and by comparison we are talking of the size, the magnitude, as to whether this is greater than this, right? So that is what we are going to look at. We are going to compare the magnitude or the size of fractions to know which one is bigger, which one is smaller, right? Now we have two forms of comparison of fractions. So we have comparison or comparing fractions in the ascending order, and then comparing or ordering fractions in the descending order. Now ascending order means from the smallest to the greatest, right? So if you have numbers like, let's say 2, 4, 6, 2, 4, 6, and I ask you, or let me say 1, 3, 2, 4, 5, 1, 3, 2, 4, 5, and I ask you to arrange it in ascending order, you just tell me that, oh, it is 1, 2, 3, 4, 5, right? So ascending order means from the smallest to the greatest, right? So that is one form of comparison of fractions, ascending order. Now when you say to ascend a staircase, it means you are at the base or you are the ground floor. So to ascend means move up, right? And then descending order is the opposite, from the greatest to the smallest. So when you say someone is descending a mountain, it means he's moving from the peak to the base, right? So that is descending order. Now here too, based on the two categories of fractions, we know how to compare fractions, right? So the way we compare like fractions differs from the way we compare unlike fractions, right? So let's start with like fractions. How do we compare like fractions? Now we compare like fractions by simply considering the magnitude of the numerators. That is all, right? So assuming I ask you to arrange these fractions, 2 over 5, 3 over 5, and 1 over 5 in ascending order. Now because they are like, because they have the same denominators, you are just going to look at the numerators and then tell me which one is bigger, which one is smaller. Then you use that analogy to what? To arrange them in order. I believe you get it. So here our answer is going to be 1 over 5, 2 over 5, and then 3 over 5, right? So it is just like me asking you to arrange 2, 3, and 1 in ascending order. So if you have 2, 3, and 1, which one is the smallest? Obviously 1 is the smallest, so 1 over 5 comes first, followed by 2, so 2 over 5 comes second, and finally 3, so 3 over 5 comes last, right? So that is how we arrange like fractions. So we just compare the size of the numerators, that is all. Okay, let's look at unlike fractions. So with the unlike fraction, we are going to use the same approach as we saw when we were adding and subtracting unlike fractions. So here we are going to find the LCM of the denominators of the given fractions, and then we will divide the denominators by what? Let's say we will ask ourselves how many times will the denominator divide the LCM, and we are going to multiply it by the what? By the numerator. So let's take this example. So we have to arrange 1 over 2, 4 over 5, 2 over 3 in descending order, meaning from the greatest to the smallest, right? So the first thing is, let's find our LCM. Our LCM gives us 30 here. So 2 into 30 is 15. Then we multiply the 15 by the 1. So 15 by 1, giving us 15. We'll come to 5. How many times will 5 divide 30? That is 6 times. So we multiply the 6 by the 4. So 6, 4, 24. Right? We come to 3. How many times will 3 divide 30? It is 10 times. What is 10 by 2? It is 20. So we've now gotten a new set of values up here. So we have 15, 24, 20. Now this means that the 15 corresponds to 1 over 2. 24 corresponds to 4 over 5. And then 20 corresponds to 2 over 3. So in now determining the order or comparing the size of the fractions, we are going to make use of these new values up here, right? So then the reason being that they now have a common denominator of 30, so it means we can now compare the numbers up here. So we have to arrange them in descending order, meaning from the highest to the smallest. So comparing 15, 24 and 20, which one is biggest? Which one is the biggest? It is obviously 24, right? And what fraction is represented by 24? It is 4 over 5. So it means 4 over 5 comes first. Now, followed by what? Followed by 20, right? So 20 is the next highest number, right? Now, what fraction is represented by 20? It is 2 over 3. So the next fraction becomes 2 over 3. And then the least is what? 15, which is represented by what? 1 over 2. So the next fraction becomes 1 over 2. So in arranging, we have 4 over 5, 2 over 3, and then 1 over 2, right? So it is the same as you adding or subtracting unlike fractions. But then this time around, you don't add, right? You just compare the new figures up here. I believe it's so demystified and well understood. Okay, let's move on. Alright, let's look at something we call the order of operations in fractions. Alright, so we've looked at the 4 operations, right? The 4 basic operations. Let's look at how we order them, or assuming we have a combination of all these operations, how do we solve the fraction with respect to the various operations, right? Now, because of the uniqueness of the operations, there is a distinct format or order in dealing with fractions whenever you have a combination of these operations, right? And that is what we have simplified, or that is what we have put in what we call the BODMAS approach, right? So the BODMAS approach gives us a particular order in which you are supposed to solve fractions, right, with respect to the various operations. So this is basically an acronym, right? So BODMAS. So B stands for bracket, O stands for off, D division, M multiplication, A addition, S subtraction, right? So brackets means whenever you're having a bracket, you solve the bracket first. So this gives us the order. So it means that whenever you have, a combination of fractions with a combination of operations, we always deal with the bracket first, right? Because B is first, bracket first, followed by off. Now off in mathematical sense is multiplication, right? So whenever you see off, it has to do with product or multiplication. So the next thing is division, followed by multiplication. So you ask yourself, what's the difference between this off and this multiplication here? Well, there are times that the question will write the word off, OF, right? So whenever it is off, it means you tackle it first, right? But whenever you just see the operation, then it means that the division comes before the multiplication, right? So the A is addition, S is subtraction. So after multiplication, you move to addition and then subtraction, right? So this is the order of operations as far as fractions are concerned. So let's take this practical example. So we have to solve 3 over 4 divided by 1 whole number 1 over 4 times into bracket 1 whole number 1 over 2 minus 2 over 3. Alright, now let me give you this guideline, this principle. And whenever you have fractions, okay, whenever you are solving fractions, the first thing you have to do is make sure you change all mixed numbers to improper fraction. Make sure you change all mixed numbers to improper fraction, right? So that is the first step you do even before you apply the BODMAS. The first thing is convert all mixed numbers to improper fraction. So it means we have to change 1 whole number 1 over 4 and then 1 whole number 1 over 2, right? So in doing that, you're going to have 3 over 4 divided by 5 over 4. So one whole number 1 over 4 gives us 5 over 4. So you multiply the 4 by 1, which is 4, plus 1, 5, so 5 over 4. Here 2 by 1 is 2, plus 1, 3, so 3 over 2. So that is what you're having over here. Alright, so that is the first step. Afterwards, you're going to apply the BODMAS rule. So the rule says bracket first, right? So we are going to solve the bracket here first. So we have 3 over 2 minus 2 over 3. So how do we solve this? So like we said, whenever you are subtracting or adding unlike fractions, you find the LCM. Alright, so what's the LCM of 2 and 3? It is 6. 2 into 6 is what? It's 3. 3 by 3, 9. So that is how come you are seeing the 9 here. 3 into 6 is 2. 2 by 2, 4. So that's why you are seeing the 4 here. Right. Then you are basically going to repeat these fractions. So 3 over 4 divided by 5 over 4. Alright. So let's move on. Now what is 9 minus 4? It is 5. So the result of this, the bracket, is 5 over 6. Right. So we are going to have 3 divided by 4 divided by 5 over 4 times 5 over 6. Now when we get here, that is where we apply our principles of division here. So whenever you are dividing, you reciprocate the fraction that comes after the division sign, and then you change it to multiplication. So that is what you are seeing here. So here was 5 over 4, so we just change it to 4 over 5, and then we change the multiplication sign here. So we change the division sign to the multiplication sign over here. Right, so we now have 3 over 4 times 4 over 5 times 5 over 6. Right, so here let's do some simplification. So 5 will cancel this 5, 4 cancels this 4, leaving you with 3, and then 3 goes here 1, 3 goes here 2. So basically you'll be left with 1 times 1 times 1 all over 1 times 1 times 2, giving you 1 over 2. Right, so that is how to order fractions, or that is how to solve a combination of fractions with a combination of what? Of operations. So you just follow this format, this order. Right, okay, let's proceed. Alright, so we are gradually coming to the end of this interesting topic on fractions. So let's look at the final part of fractions, and that is the word problems involving fractions. Alright, so there are times that you'll be given mathematical statement, right? So it wouldn't be in figures, right? So you wouldn't see a fraction like, let's say, 2 over 3, 5 over 4, 10 over 20. No, you wouldn't see anything of the sort. You'll be given statement, right? But then out of that statement you can derive fractions out of it, and you can analyze the statement, and then you can form some fractions or some mathematical statement out of it. So let's look at some examples over here. So 2/5 of the students in a class offer geography. If 14 students offer geography, how many students are there in the class? Right, so we have to solve this question. Right, so since we don't know the total number of students in the class, let's use any variable, a variable to represent the number of students in the class. Right, so let y be the number of students in the class. Right, now we are told that 2/5. Now what is 2/5 in mathematical sense, or how do you represent it in figures? 2/5 is simply 2 over 5. Right, so they are saying 2/5 of the students. Now the word of, like we said, is multiplication. Right, so it means 2 over 5 times the number of students, that is y. So 2 over 5 y. Right, in a class offer geography. If 14 students offer geography, so it means that 2/5 of the students represent 14, or let me say the number of 2 over 5 of the students is what? Is 14. So that is what we have represented here. So 2 over 5y is equal to 14. Right, so if 14 students offer geography, how many students are there in the class? So the next thing is you have to solve this basic equation. So in solving, we are going to cross multiply, right? Or we are going to multiply 2 by this 5, right? So we'll multiply 2 over 5 y by 5 and then 14 by 5. In the end, the 5 cancels out the 5 here. So you're going to have 2y is equal to 14 by 5. So 2y is equal to 70. Alright, then we divide both sides by 2. Alright, so we're going to divide 70 by 2, and 70 by 2 gives us 35. So our y is equal to 35. Therefore, there are 35 students in the class. So you see how we have interpreted this word problem in a mathematical form. Alright, so you just look at the wording. Right, so of, whenever you see of, it means multiplication. Now whenever you don't know the value of a particular item, you just represent it by any letter, right? Yeah. And then whenever you see the word is or are, you have to do it equal to, right? Equal to. So here means that 2/5 of the students in the class who offer geography is 14, or their number is 14. So that is how come we have 2 over 5y is equal to 14. Right. Okay, let's look at another example. So Vina spent 2/5 of her pocket money on transportation, 1/5 of the remainder on sweets, and 1/3 of what still remains on movies. If she has 13 Ghana cedis left, how much is her pocket money? Wow, what a nice question. So you have to solve this question, right? Now the first thing is, since you don't know the pocket money, you let any letter represent the amount of a pocket money. So we let P represent the amount of a pocket money, right? Now let's take each sentence one after the other, right, and analyze it. So it says Vina spends 2/5 of her pocket money on transportation, right? So when it comes to the fractions spent on transportation, it is 2 over 5, right? So the fraction spent on transportation is 2 over 5, as we are told by the question. So let's look at the second statement. 1/5 of the remainder on sweet. So she spends 1/5 of. Now of means times the remainder on sweet. So how do we get the fraction on sweet? How do we get the fraction spent on sweet? It is 1/5. That is 1 over 5 times the remainder. So it behooves us to find the remainder first before we can find the fraction spent on sweet, right? So how do we get the remainder? Now if she spent 2 over 5 on transportation, what is the fraction left? So the fraction left is simply 1 minus 2 over 5. Like we said, fraction is a part of a whole, right? So the whole is always 1. The whole is 1. So to get a remainder, we take 2 over 5 out of the 1, out of the whole, right? So we have 1 minus 2 over 5, and that gives us 3 over 5, right? So this is the remainder, or the fraction left. Now we can now find the fraction spent on sweet, which states that it is 1 over 5 times the remainder, 1/5 of. So 1 over 5 of the remainder. Of means multiplication. So the fraction spent on sweet is 1 over 5 times the remainder, which is what? 3 over 5, right? So when you multiply it, you're going to get 3 over 25. So this is the fraction spent on sweet, right? Okay, let's move on to the third statement. And 1/3 of what still remains on movies, right? 1/3 of what still remains on movies. So this one too means 1 over 3 times, of means times the remainder after spending on transportation and sweet. So here too, it is imperative on us to find the remainder first before we find 1/3 of the remainder. So how do we find the remainder? So we take the two fractions spent out of the whole of 1. So far we spent 2/5 on transportation and 3/25 on sweet. So let's add them, right, and then subtract everything from 1, right? So we're going to have 1 minus the sum of 2/5 plus 3/25, right? And that gives us 12/25. So there is a fraction left after spending on transportation and sweet. Then we can find 1/3 of this fraction left, of this remainder. Right, so if you want to find the fraction spent on movies, it is going to be 1/3 times the remainder, which is what? 12/25. Have you seen how we are doing it systematically? Yeah. Let's move on. If she has 13 cedis left, right, that is after spending on transportation, sweet and movies, if she still has 13 cedis left, how much is her pocket money? Right, so how do you find a fraction left after spending on all these 3 items? It's simple. Just add up the total fraction spent. So add the fraction spent on transportation to the fraction spent on sweet to the fraction spent on what? On movies. Add everything and then subtract everything from 1, the whole. So add 2/5 to 3/25 to 4/25. Right? Sorry, let's rectify something over here. Okay, let's rectify this mistake. Okay, alright, so let's rectify. Let's see whether 1/3 times 12/25 gives us 4/5. So let's see, 1/3 times 12/25. Oh, sorry, so there was a little typing error here. So it's supposed to be 4/25, okay, but then we have it here to be correct, right? So fraction spent on movies is 4/25. So please take note, it is 4/25, right? Okay, so our fraction left is going to be 1 minus the sum of all these, so 2/5 plus 3/25 plus 4/25, and that gives us 8/25, right? So there is a fraction left, and we are told that if she has 13 cedis left, how much is her pocket money? So it means that 8/25 times her pocket money will give you 13 cedis. I believe you get it. Yeah, because we are told that after spending on all these 3 items, after spending on transportation, on sweet and on movies, she's left with 13 cedis. So we ask ourselves, what is the fraction left? So we add up the fraction spent on transportation, right, that is 2/5, to fraction spent on sweet, 3/25, to the fraction spent on movies, 4/25, and then we subtract the total from the 1. The 1 represents the total, the whole, right, and that will give us 8/25. You can use your calculator to verify. Okay, 8/25. So how do we find her pocket money? Now we can equate the fraction left to the 13 here. So it means 8/25 of her pocket money is equivalent to the 13 cedis that was left, right? So yeah, we are going to multiply the 25 by the 13 up here. So you're going to get 8p is equal to 13 times 25, right? So we have 8p is equal to 325. Then we divide both sides by the 8, right? So when you punch it on your calculator, you're going to get 40.625, right? And then we approximate it to 2 decimal places. So we have 40.63. 40.63. So Venus pocket money is what? 40.63 Ghana cedis, right? So that is how to solve word problems involving fractions. So you just take each statement and then you analyze it gradually or systematically, right? Analyze it systematically. Right? Math is a language, right? So, and in any language you have to understand. Understanding is key, right? Understanding is key as far as any language is concerned. right? So you try to read it and then you interpret it in a mathematical sense. So if you are saying 2/5 of, you know that of has to do with multiplication, right? And you know that 2/5 is what, 2 or 5. And whenever we are talking about fractions, the whole is always 1. That is why I kept subtracting the fraction from what, from the 1, in order to get a remainder, right? Yeah. So this is a general overview of fractions, right? So this is where we bring the entire lesson to an end.